Hello everybody, thank you for joining me today. My name is Munam and today we're going to be looking at atomic structure. Now, whilst this is a topic that's usually taught in chemistry, we also need to understand some physics about the atom. So some of our learning objectives include to understand the structure of an atom, to understand how elements are represented in equations that we use in physics, and to recall the term isotope. So let's get right into it. Okay, now let's have a look at the model of an atom. So straight away, we have to understand that atoms don't actually look like this. We actually don't even know what atoms look like at all because atoms are smaller than the wavelength of light. So that means that light particles, right, photons, they can't actually hit an atom. They'll just pass straight through because they're far, far, far bigger than it. So we can't actually directly observe atoms, but scientists build models to help us think about atoms. So atoms are made up of three main parts. Here we have electrons, protons, which are these positive ones here, protons, and neutrons here. Now let's first look at electrons. So you know what? Let's first look at this center piece here, right? This collection of mass here called the nucleus. Okay, so the nucleus, let's just write here, is the center region of the atom. It contains most of the mass of the atom here. Contains most the mass. If you have a look at our picture here, we can see that the largest number of particles are in the center of the atom, right? We can see a few of these scattered around it, but the most are in the middle. So therefore, the nucleus, the center of the atom, the center region of the atom, sorry, contains most of the mass of the atom. Okay, so the nucleus contains protons, which are positively charged, right? I just remember P for protons, P for positive, right? So they're both positive charge, and then they also contain neutrons. Now, neutrons, N for neutrons, N for neutral, they're neutrally charged. They have no charge at all. Neutrally charged. Now, then we also have this particle here called electrons. So electrons orbit the nucleus in fixed distances. Okay, as you can see, like these circles around, these represent the path an electron follows around the center of an atom. All right, sorry, around the nucleus. So these electrons, they orbit the nucleus in fixed distances, and they are negatively charged. Negatively charged. Now, another thing that you need to know about the atom is that the number of electrons, so let's say that's Ne, so number of electrons is equal to the number of protons. So that means that the overall charge of an atom is neutral. Overall charge is equal to 0. So we can represent charges with numbers as well. So +1 is positive charge, 0 is neutral, and minus -1 would be negatively charged. The number of electrons, so these are the negative ones, are equal to the number of protons, which are the positive ones. So if we do, say we have 2 protons, so +2, and then we have 2 electrons, -2, that just gives us an overall charge is 0. So the atom is overall neutrally charged. Okay, so now let's have a look at a few different types of particles, right? So here we have regular old atoms, right? These contain 0 overall charge. Remember that 0 means that they are neutral. And we then have something new called ions. Now, to understand ions, we have to go back to our atomic model. Here we have our nucleus, right? Which is dense and contains all of our protons and neutrons. And then around it, we have our orbits of electrons. Now, these orbits are actually very special because in each orbit, only a specific number of electrons can actually exist. So in our first orbit, only 2 electrons can exist. And now our next orbit, only 8 electrons can exist. So 2, 4, 6, 8. Okay, now ions, right, has to do with the number, if an atom has gained or lost electrons. So if we go back to electricity and we think about the process of ionization, that was when strong electric fields can strip away electrons from the outermost shell on an atom, leaving it charged. When an ion is formed when an atom loses or gains electrons. So these are charged particles. Charged, G particles. Now, to understand what charge the particle actually produces, right, has when it loses or gains electrons, we just work through the logic, okay? If an atom was to lose an electron, electrons are negatively charged particles. If we're losing an electron, we're losing a little bit of that negative charge, so we can say that the atom has become positive, because remember, positive charge is really the absence of electrons, because we're not talking about the nucleus here, we're talking about the shells. So when an atom loses electrons, it gains positive charge, and when it gains electrons, now we're adding on even more negative charge to the shells. It's gaining a negative charge. Okay, so now we understand ions. Isotopes, so these are very important when we later move on to fission and fusion, right? Isotopes are atoms of an element that have the same number of protons, but, and this is the key bit, different number, oops, that looks like a H, neutrons. Okay, this is a very important definition that will come up time and time again as a simple 1-mark answer. So please make sure that you memorize this and you really understand it. So isotopes are atoms of an element that have the same number of protons but a different number of neutrons. Now remember, so we're talking here about the nucleus of an atom over here. So that's where the protons and neutrons reside. Okay, if you can understand these three things and you understand the definition for an isotope, you now understand these three particles that you need to know for your GCSE radioactivity. Alright, so here I have on the screen 4 different symbols, or rather equation symbols, that you need to be aware of for your GCSE. So first of all, let's start with the most simple one. Here we have X, right? So this X here represents an element. An example of this could be carbon, could be iron, could be helium, could be anything, right? This big X here is just designed to represent any element. Okay, so we understand that. Then we have this little A on top. This A is, oops, there you are, the mass number. Okay, so this really just tells you how heavy the overall atom actually is. Okay, so the mass number is made up of both the number of protons plus the number of neutrons. Okay, now if you remember, protons are positively charged particles that are in the center region of the atom, which is called the nucleus, and neutrons are also there, but then neutrally charged, N for neutral. Then we have underneath the Z number. Okay, so this is often known as the proton number or the atomic number. Okay, so this is just the number of protons. Okay, so if I give some examples now, carbon has a mass number of 12, let's do that in black, and a proton number of 6. So this tells us that the carbon atom has 6 protons and also 6 neutrons, because the way you work out the number of neutrons, right, if you look here, the mass number contains the number of protons plus neutrons, and the proton number tells you how many protons there are. So all you do to work out number of neutrons, is equal to mass number minus proton number. Okay, so if I do 12 minus 6, that gives me 6 neutrons as well. For iron, I actually can't remember right now, but for helium, I know that it has a mass number of 4 and a proton number of 2. So that means that helium also has 2 neutrons. Okay, so now we understand the atomic equation for an element. Now let's have a look at the second one here, which is a neutron, which is actually, sorry, a lowercase n. Okay, so this is just designed to represent a single neutron. Single neutron. Now, again, we can see that the number on top is the mass number. Oh, and another note about mass number, if you ever get confused about which is the mass number and which is the proton number, if you look, mass number contains the number of protons, therefore the mass number is always going to be higher than the proton number. So if you ever get confused, just remember, oh, the mass number is always higher than the proton number, and so whichever number is bigger, that's your mass number. And of course, the other one, the opposite, the proton number. So neutrons have a mass of 1, and that makes sense because we're only talking about a single particle here. And they have a proton number of 0. Well, that also makes sense, right? Proton number. That's because we're, again, only talking about a single neutron. A neutron is just a neutron, right? It doesn't have any protons, so its a proton number would be 0. Now we have a look here at the symbol for just a single proton. Single proton. Okay, so that's a P. This is actually a lowercase p. I know it looks kind of capital, but that's just my writing. Here we also have its mass number. Again, it's 1 because we're talking about one single particle, so it can only have a mass of 1. And its proton number is also 1 because, well, again, we're only talking about one proton. Then we finally have the electron symbol. Now, this is kind of special because electrons are so light that we actually don't really bother with its mass number at all, because it's actually something like 1/64,000, something like that. It's not a number that you need to worry about, but we can say that its mass is negligible, so we don't really talk about it, okay? And again, its proton number would be 0 again because we're only talking about a single electron. Now you can see here that it has a negative sign as a superscript. This is to represent that an electron has a negative charge, okay? So a negative charge can also be shown as a proton number of -1, okay? Because remember, protons are positive, so this one here is actually a +1. So to represent that a electron is negative, we will talk about a proton number of -1, okay? So now I hope you understand all the symbols that you need for your GCSE.